going and going and going. Okay. So, the next problems here are use a trig identity to set up a u substitution, then evaluate the indefinite integral. So, 48, we've got the integral of secant to the fourth of x dx, and we're told that secant squared of x is equal to 1 plus tangent squared of x. So what I'm looking for here is like things that I can rewrite, because do we know directly the antiderivative of secant to the fourth of x? No, we don't. So what I can do is I can split up secant to the fourth of x as secant squared of x times secant squared of x. So that I have the integral of secant squared of x times secant squared of x dx. Now I can use this substitution here that they've given me. And replace this so that I have the integral of secant squared of x times 1 plus tangent squared of x. And then don't forget the dx. So now the question becomes, can I integrate this? Okay. Yeah, with u substitution I can. So what is u?
1 plus tangent squared it. Or no. Or can it not be because that was
Just tangent of x.
just tangent of it?
Because I don't know, I mean I do, but taking the derivative of tangent squared isn't going to help me.
Right.
Like I want it to be something simple.
Oh, okay.
Because I know that the derivative of tangent is what? Secant squared, which I'm going to try to eliminate here.
Okay, so you don't have to take the whole part of the parentheses.
It can just be, yeah, so it can just be a piece of it.
Okay.
So tangent of x, so then like we said, the derivative is secant squared of x dx, which I have here, so I don't need to move anything around. So I now have the integral of 1 plus u squared, which I can integrate. That's why we did it that way. And then the rest of this is replaced with du. And so what is the antiderivative of 1 plus u squared?
The antiderivative is that? X.
U.
Oh, right. U plus 130 cubed plus 6.
Yep, and then we just substitute back in. So I've got the tangent of x plus 1/3 tangent cubed of x plus c.
So like for u, we didn't want to do the 1 plus tangent squared of x because why didn't we want to do that again?
The tangent squared.
Because tangent squared, the derivative of that would have been 2 tangent of x times secant squared of x.
Oh, right.
Which would have had something in there that I didn't have to get rid of. Now, if this had been, 2 tangent of x secant squared of x, then sure.
Yeah.
But it wasn't. So it's just a pin. So, like, you might have tried that and been like, oh, that didn't work, like in that one problem we did yesterday when we were like, oh, this didn't work and we needed to rewrite something. And so then, basically, I'm just not letting you go down the rabbit trail. That's not going to work right now for the sake of time because I'm trying to finish the section today.
So because we're only using one of the tangents as u, we didn't like 1 plus tangent as u. But
Right.
it
If it was just a 1 plus tangent instead of tangent squared, we would have done the whole piece.
Right.
Yeah,
Okay.
because then the derivative of that still would have given me
Still was-
secant squared. And some of it is me just like thinking in my head, like, is this gonna work?
Yeah.
Like, so when you said, you know, the 1 plus tangent squared, my mind immediately goes, the derivative of that is not something I have in the equation, so that's not gonna work.
Right,
Instead of
okay.
even writing it down and going down that path and realizing it's not gonna work.
Yeah.
It's a little bit of like mental thinking beforehand, but like if on a test, if you wrote it down and you're like, oh, that didn't work, just put like a line through it and then just be like, here's what I should do instead. Because I mean, then I can also see your process.
Yeah.
You know, and if you're still like, I can't figure out what I needed to do, I can at least see the different things you tried to do to get there, kind of thing. So let's see, another one of these, 50, the integral of 4 cosine squared of x dx. And they say that the cosine of 2x is equal to 2 cosine squared of x minus 1. So, we could do this problem without this. Okay, we could do that. We would be able to. Well, no, we couldn't. Never mind. I lied. We would have to rewrite it. Okay, because if I made cosine squared of x u, or cosine of x u, then I would have the derivative of that would be sine of x, or minus sine of x, and I don't have that, so that's not going to work. So we're going to have to end up rewriting it. Okay, so this is a double angle formula, or identity, you probably don't remember, maybe you do. But this has that cosine of 2x is equal to this. But do I have this over here? No. But can I get it to where I have this over here?
Probably.
Okay. So this is 4 cosine squared of x. But over here, this is a 2 cosine squared of x. So I'm probably going to have to end up rewriting this 4 because I don't have a 4 over here. But for the moment, let's try to get this piece by itself. So add the 1 over. So I would get cosine of 2x plus 1 equals 2 cosine squared of x, which now is pretty similar to what I have here. I could rewrite this as the integral of 2 times 2 cosine squared of x dx, because that's the same thing, just written differently. Then I can take this 2 out front, and then I have the integral of 2 cosine, or well, I'm going to go ahead and rewrite that piece so I don't have to write it again. So I'm rewriting this piece here as this. So that's going to be cosine of 2x plus 1 dx. So now I need to find u. What might that be? 2x is a good place to at least start. I think that will work. Use the wrong color. I'm trying to be consistent in my colors here. So 2x, so then du is 2 dx. So do I have 2 dx in here? Yeah, I already used that. Now, if I had left this 2 inside of here, I would have, but I pulled it out, so it's just going to end up being 1/2 du is equal to dx, so I'm just going to end up putting the 1/2 out front, and it's going to go away. So if I had left it inside or I'd taken it out, it would end up with the same thing. So this is going to be, I'll write it as 2 times 1/2, just for the sake of everyone seeing what I'm doing. Then the integral of the cosine of u plus 1 du. So the stuff out front is just going away. So what is the integral of this? What does that give me? is happening? Oh my goodness. Sine u plus c. And then just replace. So sine of 2x plus 2x plus c. All right, this next one, gonna get a little crazy. I'm just gonna be honest, but better to do it with me than by yourself. Because I've worked this problem through because I was like, gonna make sure. So I had to like scratch one of the times out because I did it wrong. And I was like, okay, let's try this again.
Oh, no.
So the integral of, and this is in parentheses, but just because of the dx at the end, cosine to the fourth of x minus sine to the fourth of x dx. And they tell us that cosine of 2x is equal to cosine squared of x minus sine squared of x. So, any thoughts about this one? How so? Because you're on the right track. I just want to know how you're wanting to do it. So, let me write it this way. I'm not going to write the parentheses every time. Just know that there's parentheses there because of the dx. So, cosine squared of x squared minus sine squared of x squared. And then the dx obviously is with everything. Does that help you see what maybe is happening? This is a special type of factoring, but you're probably not going to recognize it in trig form. If I have something squared minus another something squared, like x squared minus y squared, what would you tell me that that factors into? What would that factor into? Okay. So, I have x squared minus y squared here, but x is the cosine squared of x and y is the sine squared of x. Okay? So, when I do this, I'm going to have the integral, and then in parentheses, cosine squared of x minus sine squared of x times cosine squared of x plus sine squared of x dx.
So then we can substitute.
Yep. So then now I have something I can substitute in. So I have the integral of cosine 2x times cosine squared x plus sine squared x. What else do I have here? That equals 1. Cosine squared plus sine squared is equal to 1. It's a Pythagorean identity. I'm just going to reference it over here since Nathan's not here. So we have the integral of cosine 2x dx. So now, what is u?
2x,
du is
2 dx.
2 dx, which means 1/2 du equals dx. So I've got 1/2 the integral of the cosine of u du. What does that integral give me?
Sine 1/2 sine u plus c.
1/2 sine of u plus c. So 1/2 sine 2x plus c. So obviously the first little bit of this one, you might have eventually figured it out. I mean, Ethan was on the right track with the factoring thing. Did you see, was this what you were trying to tell me to do initially?
Yeah, I just think remember the term difference equation.
Yeah. So, look for things like that. Think about, can I rewrite this into something I do know what it is mathematically? It's like almost like doing substitution in a different sense. But things like that to kind of try to help you when you have to do a substitution like that. Because we couldn't have just used u substitution and gotten this either. Like, we had to substitute for this identity to have been able to solve this one. The last stuff in this section is u substitution with integration in terms of, like, definite integrals. So they've got, like, from, 2 to 5 or something like that as the integral. So we're doing the same thing, u substitution, but then evaluating it as a definite integral.
Man, I'd rather them be indefinite. I don't know.
I know. Well, that's what I kind of like indefinite better because there's not like the extra like algebra step at the end, but
it's like I know how to do it. I just don't.
Yeah. We'll start with an easier one. 54. We've got the integral from 0 to 1 of r times the square root of 1 minus r squared dr. So, what is u? 1 minus r squared.
Without the square root.
Correct. So then the derivative of that is
2r,
negative 2r
dr.
dr. So then I have an r, but I don't have a negative 2, so negative 1/2 du equals r dr. So this negative 1/2 is going out front. Then I've got the integral from 0 to 1 of the square root of u, which I'm going to write as u to the 1/2, just because, again, makes it easier. Du. So then what does that give me? And because it's definite, I don't need the plus c part. So then I can also take this 2/3 out. So those 2's cancel. So I'm going to have negative 1/3. And then 1 minus r squared raised to the 3/2. And then this is evaluated from 0 to 1. So I'm just going to put the negative 1/3 out front. So then if I plug in 1 minus 1 squared is, well, that's all just going to be 0. So 0 minus, then plug in 0. 1 minus 0 squared is 1 to the 3/2 is still just going to be 1. So this is going to end up being a positive 1/3 for the answer there. So like after the u substitution part, it's just back to the normal, you know, stuff from the last couple sections we've had. 58. The integral from negative pi to pi of the cosine of x divided by the square root of 4 plus 3 sine of x dx. So what do we think u should be? You saying just 4 or like that whole piece?
Well, if it's sine, the derivative of that is cosine.
Well, what's the derivative of 4? Is that going to help me?
Wait. Should it just be sine x or should it be 4 plus 3 sine x?
So what would the difference be in me doing the 4 plus part or just this part? In terms of when I take the derivative? Not really anything any different because the 4 is just going to go away, right? So let's do the whole thing. A lot of times it really is the whole thing, especially when it's in a radical and especially when it's in a denominator.
Okay.
Now, again, not always, but that is, you know, pretty typical. So then what is du? So,
Gotta divide.
yeah, the goal is then to get the stuff that's on top because then that's going to be gone as my du value. So 1/3 du is cosine x dx. So I've got the integral from negative pi to pi of, and I'm probably going to go ahead and write this square root as u to the negative 1/2 because it's on the bottom, and then that way I, you know, less writing. So u to the negative 1/2 du, and then I don't want to forget that 1/3, so I'm going to put it out front. So when I take that integral, what do I get? So when I take that derivative, though, 1/2 times 2 is just u to the negative 1/2. But when I take the but what does this need to? Wait a minute.
It needs to be negative. It wouldn't be negative.
Right?
Because if you took the derivative
Yeah.
of that, it wouldn't be negative. It would be
Right.
3/2.
Yeah. I was like, wait a second. I was like, it was right in my head, but when it came out, it didn't sound right. So I was like, hold on, somebody check me, make sure I'm right. No.
Wait, that's not right.
No, it is positive. It is positive.
Wait, then. Why would it be negative?
Because when I subtract 1 from here, it is negative 1/2.
Oh.
Okay, yeah, so we're good. I was like, wait a second. I was originally taking the derivative of u to the negative 1/2 instead of the integral, so then I was like, wait a minute.
Yeah, I was also thinking
Fractions make it so complicated.
That's why I usually do the exponent first, and then I figure out what number goes in front.
Mm-hmm.
So this is going to be 2/3, and then 4 plus 3 sine x, evaluated from negative pi to pi. So I've got 2/3 times, and then 4, what's 3 sine of pi? Just what's the sign of pi?
0.
0. So that's just going to be 4. Then minus, you don't want to forget that, 4. What's the sign of negative pi? So minus 4. So that is 0 times 2/3 is 0. So all that work for the answer to be 0. Gotta love it. I was gonna be done, but I really feel like I need to show you these last two, so I guess we'll just do them. I just am like, I feel like I just need to like show you all the different kinds because I'm just like.
Yeah, I would like to see all the different kinds, so I don't mind.
So, the integral from 0 to pi over 6 of cosine to the negative 3 of 2 theta sine 2 theta d theta. Huh?
I said, okay, maybe I don't want this anymore.
But would you want to do this by yourself?
No.
That's the real question.
Rather
I
do
don't
it
like when
not
they
at
change
all.
it to theta. I don't. Just keep it X, man.
What is that?
Alright, so any ideas for what you should be?
I say sine 2.
Okay, so if I take the derivative of that, what do I get?
Cosine 2dx versus cosine. I mean d theta.
So it would be cosine 2 theta times 2, but this cosine is being raised to the negative 3.
So should
Right.
that be our U?
Because taking the derivative of sine, yes, it gives me cosine 2 theta, but I can't have like du raised to the negative 3. So that's going to be an issue. So this is, another different situation. A lot of our trig functions, we've called it like 2 theta has been our u or something like that. But in this case, we're going to need to use cosine 2 theta to be our u, because that allows me to rewrite this as u to the negative 3, which I can deal with. The problem is I can't deal with it otherwise. The sine 2 theta, I can deal with that, right? So u is going to be cosine 2 theta. So then du is what?
Negative sine 2 theta times 2. Or,
Yep.
Yeah.
And then do I have a negative 2 in there? No, so I'm going to move that over. So negative 1/2 du equals sine 2 theta d theta. So we've got negative 1/2 integral from 0 to pi over 6 of u to the negative 3 du. Yeah. So now, got negative 1/2 out here. What is the integral of this? And if you need to tell me what the exponent is before you tell me the number in front, you can. If you need to visualize it.
Oh, the exponent is -2.
Yep, so adding 1, the exponent's negative 2. So then what needs to go out here to give me this? Negative 1/2. And then evaluated from 0 to pi over 6. I've got to sub cosine 2 theta back in. So this is going to be, let's see, negative 1/2. Actually, I'm going to make this positive 1/4 because then make it easier to deal with. And then 1 over cosine. I'm going to write it this way to make it easier to see cosine 2 theta squared because I think it'll be easier to see that way. Evaluated from 0 to pi over 6. So I'm going to have the 1/4 out front. So when I plug in pi over 6 for theta, okay, I'm going to end up with 1 over the cosine of 2 times pi over 6. And then that whole thing squared. So 2 times pi over 6 would be pi over 3. So what is the cosine of pi over 3? Yes. So 1 over 1/2. And I'm going to write it this way, and then I'll flip that in a second. That whole piece is squared. Don't want to forget that. Minus, do the same thing but for 0. So this is going to be 1 over cosine of 2 times 0.
That's the cosine of 0.
And then it's being squared. Also, I should have, hold on. I need to fix this. This square should only be on the bottom. There. So wait, what did we say this is?
Is it 1?
Yeah, so that would be the cosine of 0, which would be 1. So 1 over 1. Trying to fix this so it just looks right. Okay. Just so we can visualize it a little better. So this is 1/4 times 1/2 squared is 1/4. Keep, change, flip. That gives me 4. Minus 1 over 1 is just 1. So that's going to give me 3/4. All right, one last one because I don't think we've had, well, we might have had one like this, but it was like the first day. So, very last one. Not sure what just happened there. Spazzed. From 0 to 2, the integral of e to the x dx over 3 plus e to the x. So, ideas for you?
Okay, you said look at denominator usually.
Yep. So if you have a fraction and nothing's in parentheses, or like, you know, like not a trig function with something in it, I would say look at the denominator because we're trying to get rid of that because we can't really deal with that.
It wouldn't hurt to do 3 plus ex because it would just be
get rid of.
Yeah. So we can, yeah, so it's good to try that because I don't know why I wrote 3e to the x. We'll just not talk about that. 3 plus e to the x. So then the derivative of that would be what?
E to the x.
E to the x dx. Now, normally, you know, we try not to have that, but we have an e to the x on top, right? So then we're good to go. So, we have now the integral from 0 to 2 of, I'm going to write this as u to the negative 1 du. And that was something we got a property for. So what is that? Or like 1 over u. What?
Oh,
The derivative of what gives me 1 over u? Yeah, so ln of u, and remember we want to be careful that we have those absolute value bars on there because we don't know what u is or if u could possibly be negative. Now, 3 plus e to the x, there's no way for that to be negative, so don't really have to worry about that, but still. So now, and this is going to be evaluated from 0 to 2, So I've got the ln of 3 plus e to the x evaluated from 0 to 2. So this is going to be the ln of 3 plus e squared minus the ln of the absolute value of 3 plus e to the 0. Now, this is a problem where you're going to need your calculator to get the final answer. Okay, now I'll just tell you what this is so you don't have to type this one in. This is going to end up being 0.954. Okay, because this e to the 0 is 1, so that's going to be the ln of 4, and then subtracted from this here. So this would be a problem where you would need to either leave it here or go ahead and get the decimal answer, depending on, you know, what you have. Okay, so you haven't had any homework problems yet. This is what I'm going to do, because we have done a surplus of problems. I'm going to tell you to pick a couple out of each topical section until you feel like you've got an understanding of what's going on. I'll give you my recommended problems, but if you feel like you've got it under control, then you're good. Okay? So let me flip back through all my pages here where I have problems written down and try to make sure I've got a little bit of everything for you. Okay, this looks like, did we not, I didn't give you any problems before, right? Okay. I don't have, alright, let's just do, or say, 3, 9, for 17 through 23, pick 2. I don't really care which ones. I had 19 and 23 written down on my paper, but I would say just pick 2. 23's, I mean, they give you U, so it's not so complicated. Then as far as 25 through 43, I would say pick 4. But again, if you feel like you know what you're doing, you don't need to do that many, or if you feel like you need to do all of them, that's also fine. Then (47 through 51). Now, obviously, these are odd problems. I'm just giving you, we've done pretty much all the even ones. And then 53 through 65. Again, I would say probably pick 2 of those. So 47 through 51 is the ones where they tell you the identity to swap out. So at least make sure you can swap the identities out and know how to get that set up. Once you're set up, you're, you know, pretty easy there. Okay, so the other thing is we're going to quiz on Tuesday. So that way Monday you can, if you need to finish these problems or whatever, you have questions, all that. I moved it. It was supposed to be Monday, but since we didn't finish till today, I don't want to do that without you having time to ask questions on this stuff. So we'll do that on Tuesday. However, you have a physics test on Tuesday. So the option that I'm going to give you is on, what we could do is Monday, we could do the notes for 7.3 and briefly start that section potentially. Then Tuesday could become our review day, or we could swap those two things. And then Wednesday you take your quiz. We do a little bit more with it after, wrap it up on Thursday at the beginning, and then we test on Friday so that we're done with chapter 7 before spring break. Or if we haven't quite finished 7.4, then wherever we're at by, you know, beginning of class on Thursday, we'll test up through that. And if we have to finish a few things when we get back from break, that's fine. But I'm trying to get a test in so that you don't have to worry about all this information up through then.
Yeah.
So do y'all have a preference? Are you okay with it being the same day as your physics test? I mean, I don't think the physics test is going to be that hard. I don't think this chapter is that hard, but, and then that way we can just truck on through and you're not like getting new information and all of that.
That's just the easiest thing to do.
Yeah.
Either
Okay. Let's just plan to leave it for Tuesday then. And if Monday you're like super confused over the weekend doing these problems and you're like, I'm lost, then we can make an adjustment. But let's like plan for Monday to be a review day over, and remember it'll be 6-5, 7-1, and 7-2 because we haven't quizzed on 6-5 yet. But 6-5 will not be on your test on Friday. It'll only be on the quiz because that's just trapezoidal rule and Simpson's rule.
The test is gonna 7-1, 7-2, and
7-4, and that's all for chapter 7. And I found today, I just didn't find it till the end of my planning period, so I thought that I had pulled the stuff out of the new prep book that I have for calculus that went with this stuff, and I didn't think there were really any good like slope field problems or anything like that, but there's actually quite a few good ones in the multiple choice section of the review questions, so I'm probably going to give you that Monday, just so that you have it, and that can help you review as well, because it'll be a lot of, but some of it you won't be able to do yet until we finish 7-4, because it's, exponential stuff that we haven't done yet. So, and some of it we may just not be able to get all through before Friday, so. But then that way we just have chapter 8. There's one section of chapter 9, because our book does stuff a little out of order that our book doesn't cover that you need for the exam, that it should have covered in like chapter 3. But for some reason our book does it in chapter 9, so we will have to go back and do that as well.
That's huge.
I often try to teach it when I do that, but then I'm like, well, they don't have to know it. But I went through all the AP stuff and I found you do need it. So I was like, guess I should teach them that. So it's just what happens when you take a limit and you get like 0 over 0, infinity over infinity, 0 over infinity, or infinity over 0. It's a limit rule that explains what to do when that happens. So.
Oh, I never